welcome back to my channel. So in this video we're gonna learn about a limiting reagent. So let's get started. The reactant which gets consumed first and decides the amount of product formed is called limiting reagent. So let's write the definition. The reactant which gets consumed first and decides the amount of product formed is called limiting reagent. Now let us learn the trick to solve the limiting reagent problems. Okay, so I will take just one example. Like the question is, identify the limiting reagent. Okay. And the equation which is given is A plus B gives rise to C. This is the equation, and given that 2 moles of A and 3 moles of B. Now we should find the limiting reagent of this reaction. So the tricks to solve this problem is, so first write the equation and now just note the stoichiometric positions of the reaction. So what is the stoichiometric position of A? The stoichiometric position of A is 1. Stoichiometric position is 1, and here is also 1. And given number of moles of A is 2. Let us write it. N is equals to 2 moles of A and 3 moles of B. So here, to find the limiting reagent, first we must find the value of N by SC. That is N by SC value. The N by SC value of A is, N is 2 and stoichiometric position is 1. And N by SC value of B is 3 by 1. So here 2 is less than 3. That is N by SC value of A is less than N by SC value of B, which means that A is the limiting reagent. If the reactant for which N by SC value is low, that reactant is called limiting reagent. So here in this reaction, A is called the limiting reagent. And the other reactant, that is B is called the excess reagent. Okay. And the second question is, what is the amount of product formed? That is, what is the amount of C formed? So now let's find the amount of C formed. To find the amount of product formed, that is in the equation A plus B is equal gives rise to C. Here A is the limiting reagent and its value is 2. B is the excess reagent. Then the amount of C formed will be stoichiometric position of C into limiting reagent. So the stoichiometric position of C is 1. So 1 into, what is the limiting reagent? 2. So amount of C formed will be 2 moles. So here is our question. If 0.80 moles of MnO2 and 146 grams of HCl react, then what are the correct statements? First option is 0.8 moles of Cl2 is formed, 0.8 moles of HCl remains unreacted, and third option is MnO2 is completely reacted, and fourth option is MnO2 is excess reagent. Now let's solve this problem. So here, now we'll just write the equation. MnO2 plus HCl gives rise to MnCl2 plus Cl2 plus H2O. Actually, this equation is not balanced. Now what we must do is, we must just balance it. Okay, so here Mn, here 4 Cls, so we'll just write 4 here, and H2, here 2 hydrogens are there, we'll write 2 here, 2. Now it's balanced. So the balanced equation would be MnO2 plus 4 HCl gives rise to MnCl2 plus Cl2 plus 2H2O. Okay, now what we must find is the correct statements. The first statement is 0.8 moles of Cl2 is formed. Okay, so first we must find to find the amount of Cl2 formed, we must find the limiting reagent. So first let's complete this statement, C statement, and let's check whether it is correct or not. Okay, so here N of MnO2 is 0.8 moles of MnO2, and what they said, 146 grams of HCl. They did not give number of moles, they just gave the weight of HCl. Now we must find the number of moles of HCl formed. So number of, here I am going to write the number of moles of HCl formed. So number of moles of HCl formed is weight by molar weight. So N of HCl, no? Yeah, HCl is equal to 146 by HCl is 35.5 plus 1, that is 36.5. So then the number of moles of HCl formed will be 4. So now we'll just write here number of moles of HCl formed is 4, and here the stoichiometric position of Mn is 1, the stoichiometric position of HCl is 4. Okay, now we must find the N by Sc value. N by Sc of MnO2 is 0.8 by 1, here 4 by 4. It is 0.8, this is 1. So N by Sc value of MnO2 is less than N by Sc of HCl. Then the limiting reagent would be MnO2. So here they gave the statement as MnO2 is completely reacted, which means it is the limiting reagent. So the statement would be correct. Now let's tick it. This statement is correct. And if you see the fourth option, that is MnO2 is the excess reagent, but whereas it is wrong, because actually in we have find that MnO2 is the limiting reagent, and so it can't be the excess reagent, so the fourth option would be wrong. And the next question, that is the next statement, is 0.8 moles of Cl2 is formed. Now let's check whether it is correct or not. So here I wrote the equation. Now let's find the amount of, they asked, Cl2. So amount of Cl2 formed is equal to stoichiometric position of Cl2 into limiting reagent. Okay, and stoichiometric position of Cl2 is 1 into limiting reagent. The limiting reagent is 0.8. So the amount of Cl2 formed is 0.8 mole. And they gave, the statement they have given is 0.8 moles of Cl2 is formed. So this statement would be correct. And the next statement is 0.8 moles of HCl remains unreacted. Now let's find whether it is reacted or unreacted. So here amount of HCl formed is equal to SC of HCl minus SC of HCl into limiting reagent. Because this formula is used for the reactant which is not consumed completely. Here HCl is not consumed completely. That's why we'll use this formula which I have wrote in this page. Okay. So HC of HCl is 4. 4 minus SC of HCl is 4 into limiting reagent. Limiting reagent is 0.8 moles. So here. Minus, that is 3.2. So amount of Cl2 formed will be 0.8. Amount of HCl formed is 0.8 mole. They have given that 0.8 moles of HCl remains unreacted. So this statement would be correct. So in this, 3 statements are correct and the last statement is wrong. Okay, I hope you understood the concept of limiting. And here is your test yourself question, and please do comment the answer which you have got while solving this problem. Thanks for watching this video. Please do like, share, comment and subscribe to my channel. Bye bye.